Upload your doubts on the app to get video solutions.
Water drops are falling down at regular in time intervals from a ceiling such that when the first drop is about to hit the ground, the nth drop is starting from the ceiling as shown. If h1 is the vertical distance between the ceiling and the ground, then the distance of rth drop from the ceiling is given by how much? Let's break this question. This is quite beautiful problem, okay? Because there will be a lot of concepts here which is applicable here, okay? So we have to focus on individual things here very carefully. So question is saying that these are water drops which are continuously falling down, okay? And when the first drop hits the ground, first one is hitting here in the ground, okay? This is which drop? Nth drop is started falling, right? And we have to find the distance h1, okay? Vertical distance between the ceiling and the ground, okay? Sorry, we are given with that distance, okay? H1 is the given distance, vertical distance. Then we have to find the rth distance of rth drop. Any drop here we can call it as rth drop, okay, from the ceiling. So what will be this gap? Okay, this is our question. So nth drop is over there. This gap we have to find for rth one, okay? In terms of r, of course, it will be, okay? And we have, this is our first one, okay? First thing in such problems, what you have to find is the time of fall, okay, or the time interval, correct? So let's find what is the time of fall. So first drop falling from the ceiling to the bottom one, how much time it will take, okay? So to figure it out, what we can do, we can use the equation of motion s equals to ut plus half at square. And since it is falling or dropping, when things are dropped, initial velocity is 0, so u will be 0. So the distance traveled by the first drop is h1, and it will be half, acceleration due to gravity is g, and the time is t square, right? And let me write it as capital T, that is the time period, the total time taken by the first drop to go to the ground, right? And taking it on the other side, it will be 2h1 upon g, that will be our t square, right? And time t will be equals to root under 2h1 upon g. This is the time taken by the first drop, right? Okay, this is the very important expression. Now this is the time taken by the first drop to go from the ceiling to the ground. Second concept, which is very, very important here, is the concept of time interval. Now listen very carefully. If this is the first drop, let's call it as first drop. This is our second drop. This is our third drop, right? Each drop is falling. The time between two successive drops is our time interval, delta t. So here this is our delta t, correct? This is our delta t. So delta t is the time interval between each successive drops, not between any random two drops, no, between each successive drops, delta t is our time period, right? So if this is first drop and this is second drop, the time interval will be delta t, correct? Now between first drop and the third drop, the time interval will be delta t plus delta t, twice delta t. Time interval between first and the fourth drop will be delta t plus delta t plus delta t, correct? 3 times delta t. So time interval, listen very carefully, we are building one concept. So between the second drop and the first drop, the time interval is delta t. Between the third and the first one, twice of delta t, correct? Between fourth and the first one, sir, it is 3 delta t. Between 10th and the first one, it must be how much? 9 delta t, correct? So we can make a relation that the time interval between the nth drop and the first drop, how much it will be? It will be n minus 1 into t, correct? So the time interval between the first one and the last one, that must be n minus 1 into delta t, correct? This is the time between first and the last drop, delta t, and this is nothing but our total time t, correct? Because that is the total time, delta t plus delta t plus delta till our nth drop is falling, that is our total time, correct? So now what we will do, now we can write delta t as t upon n minus 1, correct? And what is t? just now we have found. So delta t is equals to 1 upon n minus 1 into root under 2h1 upon g. This is our time interval. So what is delta t? Delta t is our time interval between any two successive drops. For rth drop, what will be our time interval? Same concept. For rth drop, what will be the time interval? So for rth drop, it will be delta tr, and that will be written here as n minus r. Sir, why n minus r? See, between the nth and the first one, it is n minus 1, right? So between n and the rth one, how much time interval in between these two? It will be n minus r. You can count them. So n minus r into delta t. And what is our delta t? Just now we have found. It is n minus r into 1 upon n minus 1 into root under 2h of 1 upon g. This is our time between, the time interval between nth drop and the rth drop. Okay. So we got the time interval. Time interval of which part? From here to here. Now we have to find the distance. So distance will be the height traveled by it. So distance is equals to s is equals to ut plus half at square. Correct? And what is our initial velocity of these drops when they are falling from the top? It is 0. So distance traveled or height of fall, okay, that will be equals to half acceleration due to gravity g. And what is the time of fall of rth drop? Delta tr whole square. Let's substitute this value of delta tr in this expression and figure out our final expression. So s will be equals to, let me go to the next page, s will be equals to half g, and what is our delta tr? Delta tr is n minus r upon n minus 1, n minus r upon n minus 1 root under 2h1 upon g whole square. So when you expand it, it will become half g n minus r whole square upon n minus 1 whole square 2h1 upon g, right? Root will cancel out. So this g and that g will cancel out. 2 and 2 will cancel out. We left with n minus r whole square upon n minus 1 whole square into h1. This is the distance traveled by the rth one. Clear? So we left with B.
Watch the complete playlist on the app Pions. Download the app now.